page 300, question 6. The mean time it takes factory workers to get to a factory, to get to work, is 35 minutes. The time can be taken to be modeled by a standard distribution with a standard deviation of 6 minutes. Let's write down the information we're given in the question. There's lots of English there. Let's write down solid numbers that we get out of that information. So we're dealing with a normal distribution. Critical piece of information. We have a mean, and we know that we use our funny mu symbol for our mean of 35 minutes, and we have a standard deviation sigma of 6 minutes. So what I've done is taken the English of the question I was given, and I've written down the 3 key pieces of information that I know. I'm dealing with a normal distribution, so a bell curve. I'm dealing with a mean of 35 minutes and a standard deviation of 6. Now, before I bother looking at the question too closely at all, I'm going to draw a picture. None of you will be surprised that a picture is part of my solution. So what I'm going to do is draw in my bell curve as well as I can. I'm going to draw in my mean in the middle. My mean is going to be 35. One standard deviation up from that mean is going to be the mean plus one standard deviation. What's that going to be? That's 35 plus 6 is 41 minutes. The mean plus 2 standard deviations is going to be 41 plus 6 is going to be 47 minutes. And the mean plus 3 standard deviations is going to be 47 plus 6 is going to be 53 minutes. And I do likewise down the other side. The mean minus a standard deviation is going to be 35 minus 6 is going to be 29. Mu minus 2 standard deviations is going to be 23, and minus 3 standard deviations is going to be 17 minutes. So very few people take only 17 minutes to get to work. Very few people take 53 minutes to get to work. Most people, the average people, take around 35 minutes to get to work. Or to give you an example, 68% of this factory get to work between take 29 minutes up to 41 minutes to get to work. So 68% of this factory's workforce take between 29 and 41 minutes to get to work. Now, let's have a look at the questions. Part 1. What percentage of the workers will take between 23 and 47 minutes to get to work? Let's look at our diagram. 23 is here, and 47 is here. Well, what is that? That is between 2 standard deviations from the mean. So that's going to be the mean minus 2 standard deviations. Sorry, let's write this out the way that we would normally write it. We have 23 minutes up to 47 minutes. Now that's going to be the mean minus 2 standard deviations up to the mean plus 2 standard deviations. Writing this in will help you a lot for keeping track of what you need to do. And now we are going to look at what we know about our percentages. So we have to have the empirical rule in our minds as we're doing these questions. And I would also draw in a separate sketch to keep track of what it is I'm doing. So I'm going between mu minus 2 standard deviations up to mu plus 2 standard deviations. So I'm looking for that area there. And I know, without having to do really any calculations, that that is going to be 95% of my group. So for part 1, I found out that what I'm asked about is between plus or minus 2 standard deviations of my group. So I am now going to have 95% of my population. 95% of my workforce takes between 23 minutes and 47 minutes to get to work. Now, part 2. What percentage of the workers will take longer than 47 minutes? I go up to my diagram and I am looking for longer than 47 minutes. So I'm going to draw a sketch of that to try and keep track of what it is I'm doing. I'm going to draw a better sketch of that. So I have my mean in here, and I have my mean plus 2 standard deviations, and I can see that 47 minutes is 2 standard deviations. So what I'm looking for is the numbers that are greater than 47 minutes, than 2 standard deviations. Drawing my picture allows me to work out exactly what it is I need to find. Now, I know that between, well, let's start with this one. I'll write this in blue. What is all of that blue down there? Well, that's going to be half. That's 50% of my diagram. Because this is symmetric, half of my graph is going to be less than my mean. So that's one thing that I can use that I didn't mention already here. The other thing I know is plus or minus 2 standard deviations away from the mean, mu minus 2 standard deviations, in between here, what way would I draw that? In between here, there is going to be 95% of my population. So I want my blue 50% plus half of this 95%. That's going to give me the percentage that is below what I am looking for. So the area that is below what I'm looking for above 47 minutes or 2 standard deviations. What I'm going to do is find out what is below 2 standard deviations, everything below, and then subtract that away from 100%, and that will leave me with what is above. So let's do that now. I'm going to have 100% minus all of this stuff, which is going to be 50% plus half of 95%. 100% minus 50% minus 47.5% to 100% minus, oh, I didn't write that out, 97.5% is equal to 2.5%. So 2.5% of our population of workers takes more than 47 minutes to get to work. That's what this means. 2.5% of all of the workers in the factory take more than 47 minutes to get to work. There's a reason I keep emphasizing what it is we're looking for. When we come to exam questions, we'll be particularly focused on the meaning of these graphs and how it is that the numbers we're working out relate to the actual situation we're describing. So that's why I keep relating back to what my numbers mean. Now, finally, part 3. If there are 600 factory workers, how many will take between 23 and 47 minutes to get to work? Well, we know that between 23 and 47 minutes is 95% of our population. So we're just looking for 95% of 600. So 95%, 95 over 100, we put that in our calculator and we get at 0.95 multiplied by 600 is 570. And again, we have a focus on what it is we're looking at here. That means 570 workers. 570 workers out of our 600 take between 23 minutes and 47 minutes to get to work. So as you're doing these questions, be very clear with yourself about what it is you're looking for, what it is you're finding. And that's what we need for now.